Hi everyone, I'm Erica Cartmill, and I'm absolutely thrilled to be presenting in the symposium for Susan Golden Meadows Rumelhart Prize. I was Susan's postdoc at the University of Chicago for 5 years, working on co-speech gesture and parent-child interaction in hearing children. I came to Susan's lab having completed a dissertation on gestural communication in great apes, and with an eagerness to learn about gestures in apes' closest living relatives, us. In my lab now, I combine work on both humans and non-human primates, asking questions about gesture, social cognition, and parent-child interaction. Today I'm going to talk about the evolution of human language, an overarching theme in my work, and one of the many areas of research where Susan's ideas have been nothing short of transformational. My talk today will highlight 2 themes in Susan's work that have significantly changed the way people think about language and its likely origins. The first is her work on the importance of gesture when it accompanies a conventional linguistic system, like speech or sign. The second is the way gesture takes on linguistic features when it's used in the absence of a conventional language, as happens in home sign or during silent gesturing. Susan's work on the role of gesture in language acquisition, learning, and reasoning has caused scholars to start taking gesture more seriously, to look at it as an integral part of language and as a window onto the mind, revealing the unspoken reasoning and mental representations of speakers. Her work on the home sign systems profoundly deaf children create when they're not exposed to a conventional signed language has revealed that many core properties of language emerge in children's communication, even without an accessible model of what language should look like. This has led scholars to take more seriously the proposal that humans have an evolved capacity for at least some aspects of language, rather than acquiring all of the properties of language through observation of a language model. So, how does one ask questions about the origins of language? Language doesn't fossilize, except of course once humans developed writing systems. Now, while scholars generally agree that the earliest writing systems emerged more than 5,000 years ago, there is older evidence of written symbols. Pictographic symbols were carved into tortoise shells and bones as early as 8,000 years ago. However, we know that writing is a fairly recent invention. Language itself is much, much older, so scholars look for evidence of symbolic culture or hierarchically structured planning as indications that some type of language might have been present. Here are a few milestones from the archaeological record that suggest some type of manipulation of symbols or sophisticated tool making was present. These would have required cultural transmission, and thus are likely indicators of some type of enhanced communication. The archaeological record might tell us when human ancestors were likely using language, but it can't tell us a lot about what those earliest forms of language might have looked like. To do that, we can look either at how humans communicate when they haven't yet acquired a language, or at how our closest living relatives communicate. These approaches are used to gain insight into the communicative forms and structures that precede or underlie language. Comparative approaches to language origins typically compare features of communication in non-human animals to features of human language, and then try to identify commonalities and differences. Commonalities can indicate which features are present in both systems because they were present in the last common ancestor. Differences can be used to infer which features likely evolved in humans only after their evolutionary lineages split. One problem with this approach is that we usually compare animal communication systems to features of contemporary human languages, which are products of cultural evolution. Until Susan's work on the structure of home signing systems, no one knew whether the core linguistic features present in both spoken and signed languages around the world were the product of similar processes of cultural evolution or constraints from linguistic communication, or whether they were deep-rooted properties of the human mind. To know that, you'd have to look at the communication of humans who had not been exposed to an existing language. These are hard to find. Susan's work with home sign opened the door to this possibility and revealed that many features of human language, like noun-verb distinctions and negation, are resilient to input and emerge even when children do not have a language model. So now we have a clearer model of what fundamental properties of human language are. We can look for evidence of these properties in the communication system of other apes. All species of non-human great apes use both gestures and vocalizations to communicate. Since human languages are predominantly spoken, it seems to make sense to look at the vocal communication of apes as a comparative system. However, many studies focus instead on the gestures of great apes, comparing them to both human language and human gesture. Why should we look at the gestures of great apes as a comparative system? Because their gestures seem to be more malleable and flexibly used than their vocalizations. Apes are also able to learn new manual actions, but not new vocalizations, through cultural transmission. Many have argued that this makes primate gestures a better model for the precursor of human language. Combined with evidence that gesture emerges before speech in child language, this has led some scholars to propose that human language first evolved as a purely manual or primarily manual language. These are often called gesture-first theories. Ape gestures share many features with human language. They're used intentionally, with evidence of goal-directedness, persistence, and flexibility. They're used with sensitivity to the visual attention of others. You don't gesture behind someone's back if you want to communicate with them. They're used to solicit particular responses. Apes will modify their gestures if they don't receive the desired response. And they're combined into sequences with other signals, both gestural and vocal, though signals in a sequence typically have the same meaning. If you're interested in learning more, these features of ape gesture are discussed by a wide range of scholars in a recent special issue of Animal Cognition I edited with Kat Hobater. Now, I'd like to show you some examples of ape gesture. Here, you see a mother orangutan and her adolescent son relaxing together. In the video, the mother raises her hand in a loose, open fist, a gesture I found to be an invitation to play in my work on the semantics of orangutan gesture. What I want you to notice in the video is the way that the mother moves her body and her gesturing to remain visible to her son as he walks behind her. Just like humans, apes are also capable of gesturing with parts of their body other than their hands. Here, you will see an adult male orangutan produce a facial gesture towards his infant son. Notice how he holds his position until the infant starts to respond. And finally, I'd like to show you a more subtle sequence in which multiple gestures are combined to achieve a goal. Here you see an adult female with her infant daughter and her adolescent daughter. The adolescent is grooming the adult at the start, but the adult performs a series of gestures to get the adolescent to stop. First, she leans away, then she taps her daughter on the hand, and then when her daughter looks up, she performs a subtle flicking gesture with her fingers as if shooing her away. Lean, tap, look, flick. Ape gestures are flexible, goal-directed, malleable signals. They share these features with human communication. But ape gestures are also limited in many ways. They aren't words, they don't follow any syntactic rules, and they don't appear to be culturally transmitted. I'd like to discuss two particular ways ape gestures differ from human gestures. First, they don't serve as a bridge between action and representation in the same way that gestures seem to in humans. Building this bridge might have been a particularly important step in human evolution. Second, they're not typically combined with vocalizations, at least not in the way human gestures are. First, ape gestures don't serve as a bridge between action and representation. It's clear that humans gesture not only to communicate, but also to aid cognition. We sometimes describe this as gesturing for the speaker rather than for the listener. Although we can't conclude that ape gesture has no effect on their cognition, it's safe to say that their gestures don't contribute to building mental representations the way humans' gestures do. There's no evidence that apes use gesture in a truly representational way. Using manual gesture to simulate and represent actions and objects outside the context of acting on real-world objects represents a cognitive leap in hominid evolution. It's possible that increased demand for accurate tool manufacture in human ancestors drove many cognitive developments, including neural lateralization, representational gestures, and complex manual imitation. In contrast to human gestures, ape gestures show a profound lack of iconicity, which would be a clear indication of their representing actions or events. There's also no evidence that apes gesture for themselves to aid cognition, except possibly in language-trained apes using symbols when they are alone. It seems likely that humans' ability to use representational gestures that simulate actions or events is linked to our capacity for pretense and acting as if, more generally. My group looked outside of the communicative realm and found preliminary evidence for apes acting as if in playful teasing events. But even if apes have some capacity for pretense, there's no question that humans are capable of qualitatively different kinds of pretense and gestural representation than other apes are. The lack of iconic gesture in apes, together with the relatively late development of iconic gestures in human children, presents a problem for theories of a purely gestural origin of language. Many of these theories propose a stage of iconic gestural pantomime before the emergence of conventional symbols. Limited iconic gesturing in apes and young children doesn't mean that a pantomimic proto-language is impossible, but it does suggest that the representational abilities of human ancestors would have to be fairly advanced before pantomime became a useful communicative tool. Turning to the second point, that ape gesture is not aligned with vocalization in the way human gesture is. In human infants, vocalizations and arm movements start to synchronize as early as 9 to 15 weeks of age, long before they start using language. In hearing humans, gesture is tightly coupled with speech, both temporally and semantically. We perceive even minuscule temporal misalignments between the two. Apes can use gesture and vocalizations together in the same communicative act, but they don't show the same temporal synchrony present in humans. In ape studies, multimodal communicative acts are often defined as gesture and vocalization that occur within seconds of one another, rather than simultaneously. It might be better to think of these as multimodal sequences or bouts. Now, there's some tantalizing evidence that when apes produce both gesture and vocalization, it's processed differently in the brain, particularly in areas associated with language processing in humans. A PET study by Tagliatella et al. studied activation in the brains of 4 chimpanzees during a communicative task and during baseline. It found that the 2 chimpanzees who produced an attention-getting vocalization, along with their begging gestures, showed greater activation in the Broca's area homologue than those who produced gestures alone. The coming together of hand and voice was critical in the evolution of language. Human language certainly can take on predominantly vocal or gestural forms, now that humans have the capacity for language, but the co-presence and synchronization of both modalities may have been critical in sparking the emergence of language structure. An increase in the representational potential of gesture in the early hominin lineage, along with the synchronization of gesture and vocalization, may have provided a catalyst for the emergence of an open-ended, representational, multimodal precursor to human language. Susan's influence on theories of the evolution of language is difficult to overstate. She's demonstrated that spoken language is inherently a multimodal system, with speech and gesture each contributing unique elements, and she's helped clarify what humans bring to the table in learning a language. Her work with home sign has revolutionized our understanding of the core features of language, particularly those that emerge spontaneously in children who have no access to a language model. Of course, Susan's influence extends far beyond the worlds of primate communication, language evolution, and gesture studies. You've already heard from others about many of the ways her work has influenced scholars working on language acquisition, child development, and education. I'd like to end by giving you an example of how Susan's work is influencing a field as far away from her own as archaeology. Recently, I collaborated with an archaeology graduate student at UCLA's Coatson Institute to study the ways in which gesture was depicted on ancient Mayan artifacts. We created a gestural coding system looking at hand shape, arm position, gestural complexity, and accommodation to other speakers. Applying a conversational coding system to depictions of static gestures might seem like an odd choice, but we found that figures with higher social status according to traditional archaeological analysis, used more complex gestures and were less likely to angle their gestures towards their interlocutors. This type of categorical coding and statistical analysis is very unusual for historical image analysis, but it was well received, and if it becomes adopted by others, you may very well find Susan accepting an award at an archaeological conference one day in the future. I'd like to end by thanking my funders and institutions for supporting my work, you all for listening to my talk today, and most importantly, Susan Golden Meadow for her inspiration, ingenuity, and enthusiasm. Thank you.